Dun-dum, 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 dun-dum. Welcome back to another chemistry video. We are talking about solution stoichiometry this time. Solution stoichiometry is the idea of using concentration or liters or mass or moles or whatever to calculate the mass or concentration of an additional substance. The example we're talking about right now is ammonia and phosphoric acid solutions are used to produce ammonium hydrogen phosphate in fertilizer. That's not totally true. They're used to create ammonium dihydrogen phosphate, but that's whatever, neither here nor there. Let's try this out. What volume of 14.8 moles per liter ammonia is needed to react with 1 kiloliter of 12.9 moles per liter phosphoric acid? Holy guacamole, that's a lot of information. Take a deep breath, relax. Remember that the first thing we need to do in a stoichiometry problem is create a balanced chemical reaction. Ammonia and phosphoric acid will react, so let's write that down. Ammonia, aqueous, and phosphoric acid, aqueous, are going to react to produce ammonium hydrogen phosphate. Now, ammonium hydrogen phosphate is an ionic compound. Ammonium is +1. Hydrogen phosphate is -2. So we need 2 ammoniums and 1 hydrogen phosphate to make a neutral compound. Sure, no problem. 2 ammoniums and 1 hydrogen phosphate to make a neutral compound. So let's go through. We have our skeleton equation. Let's balance this bad boy. Let's try this out. I've got 1 nitrogen, I've got 2 nitrogens. So basically the ammonia is going to steal a hydrogen. The ammonia is going to steal hydrogen off of phosphoric acid. It looks like we need 2 ammoniums, so we need 2 ammonias. So 2 nitrogens, 2 nitrogens. We have 6 plus 3 hydrogens. We have 4 times 2 is 8 plus 1, so 9 hydrogens, good. And then we have 1 phosphate and 1 phosphate, no problem. So this is totally balanced right now. We just had to double the amount of ammonia in this reaction. So we've got a balanced chemical reaction. Every time we do a balanced chemical reaction, we always have to write our puzzle pieces below that. So we want to write our puzzle pieces below here. Let's see what information we have. It says what volume of ammonia. So we are looking for volume of ammonia, but we also have 14.8 mole per liter ammonia. So let's write that down. 14.8 moles of ammonia in every 1 liter of ammonia. All right. What other information do we also have? We have 1 kiloliter of phosphoric acid, 1.00 kiloliters H3PO4, and we have 12.9 mole per liter phosphoric acid, so 12.9 moles of H3PO4 in every 1 liter of H3PO4. That is the definition of concentration, no problem. What else do we need? Well, if we want to convert from the amount of this to the amount of this, we're going to have to deal with moles. And the way we convert from moles of one thing to moles of another thing is through our molar ratio. So let's make our molar ratio off to the side here. Molar ratio is always unknown over given, so 2 moles of ammonia will react with 1 mole of phosphoric acid. Perfect. We have all of the tools that we need in order to be able to do this problem. Now, what do we always start with? We always start with what you want. Start with what you want. Start with what you want. Perfect. Let's start with what you want. We want volume of ammonia. Volume in liters of ammonia. What's the only thing that has liters of ammonia in it? Well, it's our concentration, but it's in the wrong side of our fraction. That's in the denominator, and we want it in the numerator, so we will just flip it. We want 1 liter of ammonia has 14.8 moles of ammonia in it. So this is the unit that I want. Liters of ammonia, and I want to get rid of every other unit. So I want to get rid of moles of ammonia. How do I get rid of moles of ammonia? We're going to use our molar ratio. 2 moles of NH3 will react with 1 mole of H3PO4. Perfect. So moles of ammonia cancel out. We turned it into moles of phosphoric acid. How do I cancel out moles of phosphoric acid? Well, I'm going to use the concentration of phosphoric acid. 12.9 moles of H3PO4 over 1 liter of H3PO4. So moles of H3PO4, moles of H3PO4 cancel out. I have liters of H3PO4. Thankfully, the only other piece of information I have is 1.00 kiloliters, so 1,000 liters of phosphoric acid is what we're using in this example. Liters of H3PO4, liters of H3PO4. But you'll notice that I'm left with kilo. So I'm going to be left with kiloliters of ammonia. Those are my 2 units, or that's the 2 things that I have left, the only 2 things that did not cancel out. If I put this, if I put this into my calculator, I'm going to get, let's see, 1 times 2 times 12.9 times 1 divided by bracket 14.8 times 1 end bracket. I should get 1.74 kiloliters of ammonia. Perfect.